A tsunami of digital data greets us each day. Images, media, text. Information is moving at the speed of light, leaving many in the dark.
There's just an overload of new information that it's impossible for a student to learn everything. And so it makes for some very difficult decisions about what should a student learn.
Answers may come with the help of advanced brain imaging. Basic scientific understanding of how the brain works is helping educators and policymakers develop more efficient teaching tools.
Does one match two?
It's a very exciting time right now. We have neuropsychology. We're being able to look within the brain and see how learning is reflected in the brain.
This new science of learning has important implications for education and its challenge of what to teach, how to teach, and what students should learn.
It is a complicated and demanding task. The excitement for us in the learning sciences is we're hard at work at making that task more manageable. Basically, you do an analysis, a new analysis each year, right?
Andy Porter directs Vanderbilt's Learning Sciences Institute, an interdisciplinary research group that tackles the issue of learning from different perspectives.
When you bring together people who are trained in fundamentally different ways, who speak different languages, we all have our jargons, and it makes communication difficult when we come out of our disciplines to work together. So it's not easy, but when it does work, it's spectacular.
The learning sciences is a new and emerging field of study with three areas of interest: how people learn, effective teaching and curriculum, and policy innovations. To succeed, timing is everything.
Now's the time, now's the time, now's the time.
The time?
Time to buy a brand new 88 Oldsmobile.
Remember the 50s? Sleek cars, funny fashions, scary mushrooms. Some things make a lasting impression on the brain.
This experiment will take about 20 minutes.
Once the brain has filed that information away, it can retrieve it with astonishing speed decades later.
In order to understand that, we study people who are experts in certain categories, like car experts, for example.
So the response keys that you'll be using is 1 for same and 2 for different.
A research team led by Vanderbilt's Isabelle Gauthier designed a series of experiments to evaluate how quickly auto experts and novices recognize old cars.
So if you're a car expert, this is something that you can do very fast, and we're interested in measuring reaction times and accuracy in these sorts of experiments.
The performance is terrific.
Oh, it's thrilling.
To understand the dynamics of how the brain retains information, Gauthier uses a functional MRI.
From fMRI scans, we learned a lot about where activity in the brain is for certain tasks.
While lying in a high-tech scanner, subjects were shown pictures of faces, objects, and automobiles. Real-time imaging allowed the researchers to identify what part of the brain became active as the person watched. What they saw surprised them.
The part of your brain that is important to recognize cars is actually the same part of your brain that is important for you to recognize faces. This is an area that's surprising.
The data indicates the brain's visual center automatically blends snippets of information about a face or an object to create a whole. Whether looking at fenders or facial features, the brain works hard to fill in the blanks.
Something that is acquired a bit implicitly, but that you do nonetheless, and that perceptual expertise becomes an important part of the skills in most of the jobs that we do, most of the hobbies that we have.
For some, a fleeting glimpse of a 1954 Buick Skylark is all it takes to release a cascade of memories. So how does this baby boomer identify cars from the 50s, 50 years later?
As psychologists, we know a lot about the brain nowadays, but we don't know a whole lot about how it gets there. The more we learn about the brain, I think the better off we'll be.
I mean, it sounds like similar to what you're doing, right, with the robot's own actions.
Brain research is always in the back of Dan Levin's head.
Have you guys been thinking about doing something where you correlate that with the vision thing?
A cognitive psychologist, he's teamed up with Vanderbilt computer engineers to build a better robot, one you can relate to.
And the question is, do the eyes on this thing, do the sort of arms on this thing lead people to think different things about its capabilities?
A desktop, a humanoid. Both are computers, but when we give them human characteristics,
Good morning, sir.
expectations and reality can collide.
Delivery from... Get the hell out of my face, Scanner.
Scientists have fantasized for decades about a future made easier by robots. We humans get to leave the mundane chores behind.
Don't be so sure.
That vision remains in a galaxy far, far away.
And so you might see a lot of real differences between robots as they're represented in movies and robots as they'll actually be useful to us in the future.
Okay, so the future doesn't look so bright. The floor-cleaning Roomba is the best-selling robot today, but times, they are a-changing.
I'm the world's most advanced humanoid robot.
Levin says, as this kind of computer technology becomes more pervasive, we'll need to understand its limitations.
So we have Isaac engage in certain kinds of behaviors.
To understand how robots are perceived, research subjects will watch a video of Isaac performing a simple reaching task.
And then we ask people, what can this thing do?
The robot's eye movements and other gestures are visual cues that humans instinctively use to predict behavior.
And maybe there's certain subtle behaviors that we can make Isaac engage in that will lead people to think different things about its capability.
It helps us advance our research in terms of what aspects is it important for a robot to have to be socially acceptable.
It's like he should be looking perfectly straight.
Projects like this are some of the first steps toward teaching computers how to learn by interacting with the world around it. We need look no further than the classroom for evidence that works. Rose Park Middle School. Preteen students walk a razor's edge between interest and apathy. Teaching is a struggle.
It's an unforgiving environment.
Nashville's newest magnet school is also one of the most challenged. The majority of students live near the poverty line.
So if we can find one instance where it's not true.
The Vanderbilt research team wants to level the playing field.
But what I'm in a classroom doing is trying to understand relations between teaching and learning. Okay, so our numbers are different.
Rich Lehrer and Leona Schabel have joined forces with classroom teachers to connect students to math and science in a deeper way.
To me, it's a lot like what anthropologists must feel when they go and come upon a culture that no one's ever seen before and they try to figure out the rules.
Are you thinking that both of those are equally good ways of adding those numbers?
Lehrer and Schabel's mission is to understand how young people think about the subject, so teachers can adjust their instruction accordingly.
Is that a space?
As important, can students become agents in that change?
Could we ever get kids like these to generate their own questions, to be comfortable in mathematical and scientific discussions?
When she adds the zeros.
Largely the answer to that has been, well, yes, we can.
So then what I did was I drew two small lines.
To spark the natural curiosity kids have.
Let's see if that works.
Special attention is paid to the symbiotic relationship between math and biology.
So now all you have to do is figure out the paces.
The idea is to reinforce the connection between the real world and mathematical concepts.
I got a 45-degree too.
We try to find gentle ways of introducing it and fruitful ways for the kids to pursue it.
Is that because that's your outlier?
The Vanderbilt researchers found the best way to understand how young people think was to ask, and then ask them to write it down.
The teacher can see it. The teacher can ask questions about it. The teacher can go, oh my goodness, it never occurred to me that he or she would think that.
Can we write this as a sentence that would make sense?
Digital video, photography, and field notes are used to record the students' work.
These are all tools of expression, so we need to track them.
I want to congratulate you on stating it so clearly.
Another valuable lesson taught, democracy.
Learning about not only what you value, but what others value and why.
5, 4, 3, 2, 1.
Teaching isn't rocket science, yet.
Got it?
But in an era of rapid technological and social change, it's clear, adaptation is the key.
One in which you're continually learning more and more and more, not only about what you do, but about how your children think and how that guides what you do.
Gautam Biswas has been spending a lot of time in the dark.
Can you teach me?
With a girl named Betty.
It was very exciting.
Their relationship, strictly instructive.
Our goal, being in computer science, has always been that we would provide supporting tools on a computer that help students learn.
Please ask me some questions.
Betty's Brain is a teachable agent, an interactive software program that turns students into teachers.
Bacteria affects oxygen.
The program teaches about river ecosystems.
But let's try and teach Betty a new concept.
Using a teach link on the program's interactive map, students introduce Betty to concepts like snails and their relationship with the river environment.
I want to say that snails consume waste, so I say that.
As new relationships are introduced, the concept map grows. The student produces a visual map of their own knowledge, a powerful teaching tool.
So there's this process of organizing your knowledge, and I think that step brings about a better understanding of the domain.
If you want an explanation, click Explain.
The students can use resources available in the program to dive deeper into the material and then teach what they learn to Betty. Always popular? The Pop Quiz.
Check out my score on the quiz. I got some quiz questions wrong.
What we have created is a system where there is a shared responsibility. The student is responsible for teaching Betty. If they don't teach her well, she does not do well.
Now, when you're teaching Betty about relationships, you go to Teach Link.
Computer science, psychology, and education researchers work together to build a computer program that will sharpen minds, not pencils.
You don't realize that you're learning as you learn. I mean, you're teaching Betty something, but you don't really realize the magnitude that you're learning.
Learning scientists at Vanderbilt, Stanford, and the University of Washington sparked Betty's Brain to life.
This has been a learning process for all of us. A primary component of that learning process has been to understand the other domain's research. So this is truly what's called an interdisciplinary project.
To fine-tune the software, Biswas is previewing Betty's Brain at this Vanderbilt summer camp for high school honor students.
And when you click that and do...
My generation was brought up in learning things visually and problem solving, as I think it will adapt more to my generation.
Thanks for questions you have asked me so far.
As a teachable agent, Betty's Brain has moved to the head of the class.
I am a smart girl.
It's not just about that they've learned about river ecosystems, but they're prepared, or they're preparing themselves to learn for the future.
We're going to spend more money, more resources, but they'll be directed at methods that work.
Signed into law by President Bush in 2002, the No Child Left Behind Act seeks to raise student achievement in low-performing schools. It does so by focusing attention on what students are taught and how well they learn.
The federal government says if you want federal money, state, you must have content standards that specify what a student is to know and be able to do.
We could do it again, right?
Funding for public schools is now tied to dozens of federal mandates. These top-down decisions are meant to steer local school policy, but measuring their effectiveness has never been easy.
It's not rocket science. Students learn best what they're taught.
The first group wanted all sides equal.
Because of the pressure on students to meet state standards, local districts are looking closely at what's being taught.
Who ultimately makes those decisions? The teacher. So I study teachers' decisions about what to teach. Can the state show growth over time?
Increasingly, school boards are turning to research-based information to support their policy decisions.
Until I see that, I'm not going to be completely satisfied.
Improving instruction through effective policy is one of the goals of the learning sciences and the focus of Andy Porter's work.
One way to calculate alignment is if you're going to do research, you're going to have tools to measure what is taught, just like we need to have tools to measure what is learned.
So is there anything alike?
To get a better understanding of how math and science is being taught, Andy Porter and a team of education researchers surveyed more than 600 teachers across 11 states.
And we content analyzed their standards and their assessments.
Displayed much like a topographical map, the data gave teachers, principals, and policymakers a revealing snapshot.
Here's what you're teaching. Here's what other teachers are teaching.
That illustrates how their classroom content aligns with state standards.
It's an empowerment strategy. It gives information to teachers that they can use then to improve their practice.
And so we need to figure out a Latin word.
More than 30 states are using these tools to measure current classroom practices against state standards, vital information educators need to improve student performance.
It's not that our schools have been failures, far from that. But one should never be satisfied with how well things are going. We got to get better.
Now the tiniest of hands can explore the biggest ideas.
I'm a federal judge.
I am a veterinarian.
You're listening to Dreams.
I'm a pediatrician at Vanderbilt Medical Center.
Nashville students sharing what they hope to become.
I design PlayStation 2 games.
I'm the President of the United States.
Not all their dreams will come true, but with the help of learning scientists, these childhood dreams may turn into truth.